Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, we'll try to do section 2.4. Just as usual, we'll do a quick review. Now we say a function is continuous at an interior point C if this condition satisfied. The limit of x goes to C is equal to f of C. Also, we say continuous at the left endpoint or at right endpoint if you have A and B. So for left endpoint, I need the continuity from right. This is the limit x goes to A plus is equal to f of x, A plus A of x. And for B, I need to do it from left. X goes to B from left. A function is continuous from the right. As we said, limit x goes to A from the right is equal to f of A. And continuous from left, and it goes to A from left of f of x is equal to f of A. We say a function is continuous in our interval if it is continuous at every number in the interval. This type of discontinuity are removable. It's discontinuous, but the limit exists at A, as it goes to A. If the limit does not exist, then depends on the reason why the limit does not exist. Why the limit does not exist. If the right not equal to left, we say jump goes to plus or minus infinity. It's infinite, oscillating. It will oscillating discontinuity. Our book is using removable and non-removable. All of these cases, you just call it non-removable. Continuous function, continuous, if it's continuous at every point in the interval. If I have two functions continuous and C is a constant, their sum is continuous, their difference, constant times f times g, and if it were g provided the denominator not equal to 0. From that, we get any polynomial is continuous everywhere. An irrational function is continuous in its domain. Okay. These types of functions are continuous on their domains: polynomial, rational, root, trig functions. Also, the inverse of the f inverse of a function of a continuous function is continuous. If you have a function is continuous at b, and the limit is equal to b, the limit of this is equal to b, and the function, I need two things. The function is continuous at b, and this limit exists. Then, to find this limit, I can take the limit inside. From left to right is the same thing. We can say it in words. If g is continuous at a, and if it's continuous at g of a, then the composite function is continuous at a. An intermediate value theorem saying what? If f is continuous on a closed interval, you have n as any number between f of a and f of b, where f of a not equal to f of b, then there exists a number c, so that f of c is a number c in AB. Does that f of c equal b? We can deal with solving this system if x equals 0. So I put n equals 0. So I want f of a and f of b to be non-zero and have opposite signs. One of them positive, the other one is negative. Then there exists at least one solution, maybe more. Okay, now let us do the problems. Okay, let us deal with these problems. I want to check when this function is continuous. If I have len, I need to check the domain of this function. So I have 2 plus cosine ax should be positive. The argument of len should be positive, and the denominator not equal to 0. And this is not equal to 0, and this is positive. If you look at these things, it's always positive. Since cosine ax is always between -1 and 1, add 2, then it will be 1 less than cosine ax less than 3. So this one always greater than or equal between 1 and 3. So it's always positive. So this is always correct. This one, I want x squared not equal to 4. So x not equal to plus or minus 2. So I need to avoid -2 and 2. So it will be the domain minus infinity to -2, this, -2 to 2, 2 to infinity. When this function is continuous, I need to find the domain. So for this, I need this to be positive. And from this, I need x not equal to 3. So this one should be positive, greater than, non-negative, I mean, greater than or equal to 0. So we just solve it. That will be x plus 4 times x minus 3, always greater than or equal to 0. We'll do the sign diagram. I think we know it. This is -4. This is 3. X plus 4 will be positive, negative, negative. X minus 3, but this is the opposite. Take a value, -5, that will be negative, positive, positive, that will be negative, positive, positive, negative, positive. I want the positive things. So I'm taking -4 is included. Taking this side. And for 3, from here is included, but I want x not equal to 3, so it will be open. And I'll also need this side. So it will be minus infinity to -4 closed, but this one is open. That's it. When this function is continuous, I need the argument of the lane, which is this thing should be positive. So I have, this is the first condition. Also, I need e minus x not equal to 0, which means x not equal to e. So if I make it, this is open at 0. E is there, so it will be from 0 to e, union e to infinity. E is just a number. X greater than 0 and x not equal to e. The same thing, we'll do the restrictions. So I have x squared minus 4 greater than, here I make it greater than 0 since it's in the denominator. And also I need this to be not equal to 0. This one is easy one, x minus 8, x plus 1, not equal to 0. So x not equal to 8, or x not equal to -1. For this one, it's an inequality, x squared minus 4 greater than 0. I can do it like this, or I can do it, I say this is x squared greater than 4, take the square root, I have an absolute value greater than 2, so I have x less than -2 or x greater than 2. So what I have from -2 to 2, I have this side and this side. This is for this condition. Now for this condition, x not equal -1, -1 is actually here. So nothing, that will not affect anything because this area is not with us. X not equal to 8, so I need to make it open at 8. So I have minus infinity to -2, union 2 to 8, union 8 to infinity, which is this. This one, what are the restrictions? I need this to be greater than or equal to 0, and I need this not equal to 0. X not equal to plus or -1. We did this before, so it will be x less than or equal -2, or x greater than or equal to 2. So we have -2, and we have the 2. But I need this side and this side. -1 is here, and 1 is here, which is already outside this domain. So that will make no difference. So the answer is minus infinity to -2, union 2 to infinity, which is this one. This function is continuous, where I need the argument of len, I need it to be positive. So we just solve it. This is 3 minus x, 3 plus x, over x plus 1 positive. So I'll make the sign diagram. Or have 3 zeros, -3, -1, and 3. 3 minus x will be positive, positive, negative. 3 plus x, I have negative positive, 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 x plus 1. I have negative, negative, positive, positive. So that will be what? Negative, positive, negative, positive. I'm looking for what? For positive things. So it will be from minus, it will be from minus infinity to minus 3, union 3 to infinity, union the positive ones, which is this and this, union minus 1 to 3, which is this one. All of them open. This one, when it is continuous, I need this one, will give me 2 minus x positive. These things give me x positive. These things give me x not equal to 1. I'll combine all of these things in 1. So that means x less than 2. So خلاص. This is greater than or equal. This is has an equality. Okay. So I have 0 open, 1 open, 2 closed. X less than or equal to 2 is this one. X greater than 0 is this one. So this is will be the intersection between all of these three, but also I need to avoid at 1. So it will be from 0 to 1, 1 to 2, but these two closed, which is this one. The function is in this interval is discontinuous. It means when it's defined, I need tan square to be positive as an argument of length. Also, notice tan square by itself is sine square over cosine square. So for sure, I need cosine square to be not equal to 0. So I need this condition, cosine square not equal to 0. And from here, what's the meaning of tan square greater than 0? This is always, we call it non-negative, or 0 can be there, but I want to avoid that. So tan square not equal to 0, which means sine square not equal to 0. So I have these two conditions, sine square not equal to 0 or cosine square not equal to 0, which is cosine x not equal to 0 or sine x not equal to 0, which is very clear. Now, this is the interval where they gave it to us, 11 pi over 10. When this is 0, x not equal to pi over 2, x not equal to pi. 0 is not included, no need to consider. So this will give me pi, and this will give me pi over 2. So I need to avoid pi over 2, and this one I need to avoid pi. Avoid pi. So x is discontinuous if x equal pi over 2 and x equal pi only. The number of discontinuity for this function, it means I need this to be positive in this interval, and I need this not equal to 0. That means x not equal plus or minus 1. Here, like what you did before, I need a cosine square not equal to 0. To see where is if cosine square is equal to 0, so I have a discontinuity. Notice this interval from 0 to 3 pi. So I have 0 and 3 pi. Cosine not equal to 0 at x equal pi over 2. We have pi over 2 here. Then it's what? Pi, you have no problem, 3 pi over 2. Okay, that will make it 2 pi, then 5 pi over 2. This is what will make cosine x 0, between 0 and 3 pi. So I have this. Let me make it good now. So I have this. This is one case, second case, third case. This is from this one. And also I have x not equal to 1, and x not equal to minus 1. Minus 1, I'm going to start from 0, minus 1 is out of the picture. 1, since pi is 3 point something, 1 is somewhere here. So also 1, I need to avoid. So how many? The number of discontinuities? 1, 2, 3, 4. 4 values. Now finding the limit. Let's go to infinity of this one. First, I need to check this. Notice tan inverse is always continuous. So nothing to worry about. This one, as we said before, is minus infinity will be 0. So that will be 1 over 0 minus 1, which is minus 1. So I have this limit equal tan inverse of the limit x goes to infinity, 1 over e minus x minus 1. And this limit, as we did before here, it's minus 1. So that will be tan inverse of minus 1, which is minus pi over 4. To find the following limit, first I need to check this limit, which seems to be very complicated, but actually it's nothing, just substitution. So that will be what? Square root 2 cosine pi times 0 cosine 0, which is plus 1 over e to the power tan 0 is 0, e to the power 0 is 1, cosine 0 is 1. So that will be square root 3 over 2. So this limit will be sine inverse of this limit, which I just did, and that will be sine inverse square root 3 over 2, which is pi over 3. So this is the answer. Tan inverse of this. First, I need to find the limit of this one, which needs a little bit of calculation, which is equal what? Limit, this goes to minus infinity. I will take x to the power 6 common factor. So I have 1. I have x is minus 6 or 1 over x to the power 6. Can make it 1 over x to the power 6 plus 4. 1 over x to the power 6 over, I have x cubed common factor. I have 1 over x cubed minus 2. That would be limit, x goes to minus infinity. This will be, you know that x goes to x cubed will be absolute value x cubed. That will be minus x cubed. Why minus? Because it goes to minus infinity, so I'm talking about negative values. So that will be minus x cubed. 1 plus 1. It will be 1 over x to the power 6 plus 4 over x cubed. 1 over x cubed minus 2. These cancelled. So limit x goes to minus infinity of minus 2. That will be what? This is 0. This goes to infinity minus is the same. That will be minus 2 over minus 2, which is 1. So this limit will be tan inverse. I take the limit inside, tan inverse of 1, which is pi over 4, which is this answer. I need to find this limit. I take it easy. X goes 0 from left. Think about sine x. This is sine x. Also, it will go on the other side. So sine x goes to what? 0. I'm going 0 from left. Sine x also will be 0 from left. So minus sine x will be 0 from right. Take the len of minus sine x. Len of 0 from right goes to minus infinity, where this is the len. Just for your information. As I'm going 0 from right, the function goes to minus infinity. So this is my answer. X goes 2 pi from the right. This is the sign. We'll go back, then this is the 2 pi. And they want X goes to 2 pi from right. So sine X goes to 0 from right. 2 pi from right. I am here. So it's 0 from right. Take ln of sine X, which is ln of 0 from right, that goes to minus infinity. So this is the answer. And to find this limit, there's a trick here. Just calculation things. Substitute. It will be sine 1 times secant square, which is secant square 1, minus tan square 1 minus 1. Notice 1 plus tan square is equal secant square. So this one, I can take it sine of 1 plus tan square 1. Secant, I just put x1 so that I'm getting this minus tan square 1 minus 1, which is this is cancelled, so I have sine of 0, which is 0. So this is the answer. This one gets integer. We need to check. Okay, check first the greatest integer. As this goes to 3 from left, 2x goes to 6 from left, 2x plus 1 goes to 7 from left. Greatest integer goes to what? So 6 point something. So this will be 6. So plug it there. So this is cosine is continuous function. So this will be cosine of the limit. This goes to 3 from left, pi over 2 of this one. And this is, we know it's going to 6. So that will be cosine 6 pi over 2, which is cosine 3 pi, which is minus 1, which is similar to cosine pi. Check this limit. First, I need to check this limit. We know that limit is goes to 0 of this one is 0 by squeeze theorem. So I have cosine of 0, which is 1. I don't think we need to check this. We did it millions of times. Not millions, but many times. Okay, number of removable and number of infinite discontinuity. First, I need to simplify the function here by grouping. So I have x squared, x plus 3, minus 9x plus 3 over x times x squared minus 9. So I have x squared minus 9 times x plus 3 over x squared minus 9. So I will deal with these three zeros, x equals 0, x equal minus 3, x equal 3, which comes from the zeros of these ones. Or I can simplify it more, is x minus 3, x plus 3, x plus 3 over x minus 2, x minus 3 times x plus 3. If you think of it, you notice for x equals 0, I have a non-zero value over 0, which is an infinity. So this is an infinite discontinuity. But for x equal minus 3, you can check the limit. Let me do it without doing the limit, then I'll do it with the limit. This is means we have a hole there. So this is removable discontinuity. The same thing with x plus 3, where I have removable discontinuity. Now, do it through the limit. Limit x goes to 0 from right. All of these cancelled, so I have x plus 3 over x. That's very clear. It will be what? This is positive. It will be non-zero over 0, so it's an infinity category, and this is positive, so this will be plus infinity. Limit is goes to minus 3 from right, of this x plus 3 over x. It will be what? The limit exists. Just substitute. You have minus 3 plus 3, which is 0 over minus 3, that is 0. So we have removable. Limit x goes to 3. That's still removable. It will be 6 over 3, which is 2. So we have 2 removable and 2 and 1 infinite. So r equal 2 and I equal 1. This he was talking about discontinuities. Just simplify. This is f of x, and this is x plus 3 times x minus 2. Correct? 3x minus 2x is x, and this is minus 6. The one is minus 3x plus 2. Very clear, the potential is x equal 2 and x equal minus t. This is a half infinite discontinuity. Not infinite, no. This will be cancelled, so this is the removable. Since the limit is goes to 2, this is cancelled. It will be what? 1 over of x minus 1 over x plus 3. That is 1 over 5. Here I have infinite discontinuity. Why? Because I need the limit is goes to minus 3 from right. X minus 1 over x plus 3. That will be negative over positive. That will be minus infinity. This one, I need to check what will happen as the limit x goes to 1 for this function. The limit, since this is taking plus or minus, so it will be x squared minus x over 2x minus 2. That will be limit is goes to 1, x for x minus 1 over 2x minus 1. Cancelled at 1, it will be half. But f of 1 is equal to 2. So they are not equal. So f is discontinuous at x equal 2, and it has a removable discontinuity. Why is that? Since the limit exists. So we have a removable, and the function is discontinuous. Same thing here, which is what? X minus 2 times x plus 1 over x minus 2 times x minus 1. So I have x equal 2, x equal 1. Here I have, this is cancelled. So I have x equal 2, x equal 1. And this one I have removable discontinuity. Since the limit exists, it will be what? 3 over 1, which is 3. And they have infinite, infinite, which is not removable, we can call it x plus 1 over x minus 1. That will be positive or positive, which is plus infinity. So I have removable at x equal 2 and infinite at x equal 1. This one, it will be what? X squared over x times x squared minus 1. That will be x squared over x minus 1, x plus 1. Our potential ones are x equal 0, x equal minus 1, x equal 1. Here, since everything cancelled, they have removable. Here, I have infinite discontinuity. You can check. This is limit x goes to 0, x squared, x. Actually, if we simplify it, provide the x not equal to 0, that will be x over x minus 1 times x plus 1. So take the limit of this function, but for sure 0 over minus 1, which is 0. Now this one, take the limit as it goes to minus 1 from right of this function. So I have non-zero over 0. That means you have an infinity category. That this will be negative. This one will be positive. No, this one is negative. And this one is positive. So I have plus infinity. So I have infinite discontinuity. If this goes to 1 from the right, that will be what? Positive, positive, positive. So that will be plus infinity. So I have one removable and two infinite discontinuities. This one, you want us to check at 0, you have no problem. You can't check it, nothing is there. So I need to check at x equal -2, what will happen. So I need to check the limit as this goes to -2 of this function. First, you notice if we substitute, we are getting 4 minus 4, 0 over 0. So there is a problem. Okay, so I need to get rid of the absolute value. This will be negative. Why? Since I'm going to -2. So this will be limit x goes to -2, 4 plus x times minus x over x plus 2. And that will be limit x goes to -2. Yeah. That will be 4 minus x squared over x plus 2. And that will be limit x goes to -2. 2 minus x, 2 plus x over x plus 2. This is cancelled. Substitute, you are getting 4. So I have removable discontinuity. A limit exists. Limit exists. But the function is discontinuous at x equal -2. And to check also removable and non-removable, I think we'll do it the same. X minus 1 over x minus 1, x plus 1. So my potentials are x equal 1, x equal -1. This is cancelled at x not equal to 1. So this is removable, and this is infinite discontinuity. Limit x goes to 1. Just I check it, x plus 1, that will be half. So I have removable, limit exists. Limit x goes to -infinity, -1, I mean. It will be x over x plus 1. That will be negative from the right, make it negative or positive. That will be -infinity. So I have one removable and one infinite. This one first you need to simplify it, and then you can judge it. This is what? X minus 2, x minus 1. So do common denominator. It will be what? X minus 1 plus 2. And that will make it what? X plus 1 over x minus 2 times x minus 1. So these are the potential ones, or the discontinuity. X equal 1, x equal 2. And they have infinite discontinuity, infinite discontinuity. Since it will be non-zero over 0, check the limit. It goes to 1 from right for this function. That will be positive. This one negative. This one positive. So I have -infinity. For this one, limit x goes to 2 from right. X plus 1 over x minus 2 times x minus 1. That will be positive, 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 and that will be plus infinity. So we have two infinite discontinuities. I think we did something similar, but let us do it again. X plus 2 over x minus 3. This is cancelled, that x not equal to 0. So I have x equals 0, x equals 3. Here we have removable, and here we have infinite discontinuity. Removable y, if we take the limit as it goes to 0, you have x plus 2 over x minus 3, which is -2 over 3. Here I have the limit as it goes to 3 from right, x minus 2 over x minus 3. It's here positive. Here you have positive, so it will be plus infinity. So I have one removable at x equals 0 and one infinite at x equals 3. For what values of b, does the function has a removable discontinuity at x equals 0? Removable means the limit exists. This is one thing. Also, x at 0 defined. So for sure, but if is not a discontinuous at x equals 0. But since f at 0 defined, that means what I have x goes to 0, that should not be equal to f at 0. So I need to check the limit of f of x. That for sure should be exist. So limit f of x as goes to 0 from right equal limit f of x as goes to 0 from left. That means what? From right, I am here. Substitute, you have 1 minus b plus 2. Left, I'm here, so it will be b. B minus sine 0, which is b. So that implies 2b equals 3. What is it? Applying 0 here. Wait. We're applying 0. So it's 0, huh? That will be minus b squared plus 2. And this one, b. So I have b squared plus b minus 2 equals 0. So I have b plus 2, b minus 1 equals 0. So I have b equal minus 2 or b equal 2. So I have two cases. Let's just check when I have discontinuity or when I don't have discontinuity. So check it, b equal minus 2. What is the limit of f of x as this goes to 2? As this goes to 0, I mean. The limit, these two should be equal. So that will be equal to minus 2. What is f at 0? F at 0 equal 1. So in this case, we have removable discontinuity because the limit exists, but not equal to f at 0. For the case v equal 2, what will be the limit as it goes to 0? It will be 2. Here b equal 1. From where I get the 2? B equal 1. So this is 1. So this is 1. And f of 0 is equal to 1. So in this case, f is continuous at x equal 0. If f is continuous at x equal 2, what's the meaning of this? It means the limit is goes to 2 of f of x is f at 2. And this limit exists. It's equal to 5, who cares? But the limit exists. Notice, like what we did before, since this equal to 0, for sure the limit of the numerator should equal to 0. Also note limit of f of 2t as t goes to 1. I have t and x, this is t, and this is t. Okay. This one, if I let x equal 2t, that will be what? Limit f of t, f of x as x goes to what? If t goes to 1, x goes to 2. And this is, I know it. It's what? F at 2. So I have here what? That implies in the limit as t goes to 1 of t squared, f of 2t minus 2t. I can distribute the limit. This limit exists. It's equal to f of 2, which is exists. This one exists. So I can distribute the limit. I know this is equal to 0. I need to find this. So that implies 1 square and this limit minus 2 equal to 0. So this limit equal to 2. Equal to. So now we need to check this limit. We know that this is equal to 2. So implies, I quoted it before, limit x goes to 2 of f of x equal the same thing, which is 2. That implies in the limit s goes to 2, x f of x will be 2 times 2, which is 4. So this is 4. Yeah, if it's continuous in this interval, and the only solution with the given equation are x equal 2, x equal 5, and the f of 3 equal 9, why all of this the only one correct and the others are wrong. Just if you graph the function easily, I know that if it's continuous between 2 and 3, 2 and 6, this is 2 and 6. The function is continuous. He gave us at x equals 7, this is x equals 7. The only solution, it means I have a point here at 2, also I have another point at 5. So this line will be crossed only at these 2 points. Open. Just at these 2 points, this point and this point. Now he give us more information. He said at 3, the value is 9, somewhere here, which is 9. This is at 3. Now he's asking about f at 4. This will be f at 4. F of 4 cannot be here. Why? Because the function is continuous, so for sure it will be connecting the points, and this line will be crossed only at these 2 points. So for sure to connect from this point to this point, I must go up. I cannot go down. So for sure, f of 4 must be less than 7. This is impossible. Now, f of 4 must be greater than 9. This is wrong if I do it like this. For sure it can be less than 9. So this is wrong. Now, if a 4 must be less than 9, no, I can't make it more than 9. This one up to 3, 4 will go up, then go down. So if a 4 is greater than 9. The point is he's making must. No, it cannot be must. Must be greater than 8. Also, this is wrong. If this is 8, I can do something like this, where at 4, I mean, the line will not cross it. So this is also wrong. So this is the only solution. For sure, and do anything that will be f of 4 must be greater than 7. I think the graph explain it. Now we have this intermediate value theorem. I'll do 3 or 4 of these. I think I'll do these 2. Okay. So as usual, we need to make it equal to 0. So this is my function, which I want to find the 0. He said the equation has at least one root in the interval. Use the intermediate value. So what I will check? I will check f of minus 1, f of 0, f of 1, f of 2, f of 3, f of minus 2. Those are the ones which I need to check. So f of minus 1, it will be what? Ln, I have what? 1 plus 3 plus 2, which is ln 6 minus 1. I know ln e is 1, 6 is greater than e, so this is positive. F of 0 will be ln 2 minus 1, which is negative. F of 0. Why it's negative? Because I know ln e, you have the function ln, when it will be 1 at e, and 2 is here. So ln 2 is negative. Ln 2 minus 1 would be negative. F of 1, I have ln of what? Ln of 1 plus 1, 3 minus 3, so it's not defined. So not defined. Then 0 it will be, 3 minus 3, then 0. F of 2, then of what? So anything with 1 would be cancelled. This is cancelled, honest. This one correct. F of 2, substitute, you have 4 plus 2, 6 minus 6, also this one out. F of 2, there's a problem, so this is also out. F of 3, no need for it, honest. Out. Actually, it will be what? Then 9, 11, 11 minus 9, which is then 2, which is negative. F of minus 2, it will be then 6 plus 6, then 12. Minus 1, which is positive. Minus 1 is positive, this is positive, this will give another F nothing, this is the only solution. The same thing, but I need to rearrange it. X cubed minus x minus 2 plus the square root of x. Check. F of 0, f of 1, f of 2, f of 3, and f of 4. F of 0, 0, 0, 0, minus 2, negative. F of 1, 1 minus 1, 0, minus 2 plus 1, that is minus 1, negative. F of 2, 8 minus 2 minus 2 plus 1, which is 9 minus 4, which is 5. So 1 and 2 is correct. 0 and 1 give us nothing, huh? Let's check 3. F of 3 will be what? 27 minus 3 minus 2 plus square root of 3, which is clearly positive. So this is out of the picture. Since this is positive, this one will be 64, 4 cubed, which is 64 minus 4 minus 2 plus 2, which is always positive. So this is out and this is out. So this is the only solution. I think I will stop here.